Help me to explain why X-ray can make the image of internal organ. What specific what specialities in the X-ray photos which can generate internal organs?
Because the amount of photons which pass through the internal organs onto the detecting instrument is different than the amount of photons that pass through the muscles and fat. So when we look at the detecting instrument, we can see an outline of the internal organs.
Why X-ray can pass through the body? Because it has high energy compared to visible photons, for example. And you said that the different transmission of photons in different organs. What changed the difference?
The difference in the density.
Density and
the
atomic number. This both is very important. And the bone has higher atomic number and density compared to, for example, soft tissue. And what's the order of the increasing of attenuation, which is dependent on atomic number? In which order increases? In
cubed.
Power of 3 cubes. If the atomic number of 1 point in the body increased or doubled, it's 8 times the photoelectric. Why the photoelectric is important in the X-ray imaging?
Because it's for absorption.
Because it absorbs the photon and
transfer its energy to electron.
When it absorbs, it will be less.
And because of this absorption, we get contrast, so we can see.
Yes. We say that the main role of the photoelectric is making contrast, because photoelectric absorbs the photons, and absorption of photons depends on the organ. And different organ have different attenuation or different photoelectric interactions. So the main role of photoelectric interaction is making contrast. And what about the scattering interactions? What we can say about that interaction?
They make the image less clear. They reduce the quality.
The quality will be decreased due to the scattering. Why?
Because the scattered photons don't tell us any information. So if we have a photon which is absorbed, we understand something. If some photon passes, we understand something. But a scattered photon doesn't tell us anything.
Because the direction change, the energy of primary photon change, and this, the information of the scattered photon is misinformation, that degrade the image quality, and so we don't like the scattering photon, but we cannot remove them. And the other question is, what about the dependence of the protocol of imaging to the patient size? Is it important or not?
Yes.
For example, if we have a thick patient, we prefer to increase or decrease the number of photons. Increase. Why?
So getting a clearer picture, because it needs to go deep inside.
If we use very low number of photons, what will happen in the thick patients, do you think?
We won't be able to see anything because all the photons will be absorbed.
Yes, most of the photons attenuate inside the body, and there is nothing to reach to the detector. We need photons to reach to the detector after patient. If we have used low number of photons in the thick patient, most of photons attenuate inside the body, and there is nothing to reach to the detector. So, if we have a thick patient, we should generate high number of photons, and with the hope of reaching some photons to the detector. So the number of photons is very important. What about the energy of photons? Is it important as well or not?
Yes, because a low energy photon won't pass
Yeah.
through the body as much as a high energy photon.
So it means that, for example, if I want to have a good image from the bones, bones has high attenuation, so I need photons with high energies. So, for example, you want to image a soft tissues. Low energy is enough. But if you want to image high tissues with high atomic number and attention, it's better you have high energy photons to help to transmit the patient. So we should adjust two main parameters. First, the number of photons. Second, the energy of photons. What is the name of the parameters in the controlling panel to change the number of photons? MA or milliampere? MA or milliampere?
Kilovolts.
For number of photons is MA. If you increase the MA, the number of photons which are generated by X-ray tube increase. For example, if you double the MA, the number of photons which are generated by X-ray tube will be doubled. Okay? So the intensity, we say that intensity of photon, the flux of photon, the number of photon is increased. The second parameter is energy, which is controlled by kV or voltage. Which voltage we are talking about? Which voltage?
The voltage between the anode,
Anode and cathode, which apply to anode and cathode. If you remember, the main role of this voltage was acceleration of the electron from cathode to anode. When you increase the voltage between cathode to anode, the speed of electrons which move from the cathode to anode will be increased. So the energy of electron will be increased, and when the energy of electron increase, the energy of photons which generated in the anode will be increased. So by voltage between anode and cathode, which is around kilovolts, for example, from 20 kilovolt to 150 kilovolt in normal radiology machines. When you increase this voltage, you increase the energy of electron between anode and cathode, and then increase the energy of photons, which is generated inside. And I explained about the energy, which is very important. Energy is somehow multiplication of MA and kV. Do you remember in the high school physics we have power, which multiplication of voltage and current? Do you remember it?
Yes.
Yes, the power is multiplication of voltage and current. It's the same. The same. So by multiplication, it means that how much energy we are using in this imaging process. How much energy. If you want to have a good image quality, if you have a thick patient, and if you want to see the very fine changing inside the patient body, you should use higher energy. But be careful. The X-ray photons is dangerous. X-ray photon is dangerous because the very high value of X-ray photon can make, cancer. Can make cancer by itself. Because the size of the X-ray wave is small. And it can break the DNA strings. It can break the DNA strings and leads to some new disease. So most of the time we say that X-ray is harmful. So it is not such. We can have no limitation in using X-ray energy for X-ray imaging. We should optimize. We should optimize the value of X-ray to make image. Sometimes we say that X-ray is ionizing energy. What's the meaning of ionizing? Make ions. Make ions. You saw that in photoelectric, the photon hit the electrons of the atoms and then ejected it. It means that we call it ionization. Because we have an electron and a positive ion after a photoelectric interaction. So the very high value of X-ray can be harmful for the patient body. So there is very strong standards in the world, very highly reviewed method of X-ray imaging to use an optimized value of X-ray in radiography, mammography, and in CT scan. For example, it's suggested that there should not be more than 2 times per year for one patient to doing CT scan. Not more than 2 times per year, for example. 1 times per year for mammography, because high value of X-ray can be harmful. But in the surgery, sometimes you do some cutting in the patient body, yes, some changing in the patient body to save him. Okay, this is somehow a balance between how much you put a harmful actions and how much it's useful for the patient. This is a balance. Everything in the medication, we have this balance. Most of the drugs and medication have some side effects, yeah? Between the side effects and the usefulness of a medication should be a balance. In the X-ray imaging, we have the same thing as well. The X-ray has some harmful effect and have a very useful effect. And there should be a balance between the harmfulness and the usefulness of any treatment or surgery or X-ray imaging. So let's go for X-ray detection. We talk about in the X-ray imaging chain, we have source, we have the body which attenuate, and the third ring of the chain is detection of X-ray. How we can detect the value of transmitted photon from the patient body. In radiography, if you remember, we have a source in one side, X-ray source in one side, and X-ray detector on the other side of the patient, and the patient is between source and the detector. And a large fraction of X-ray interact inside the patient's body, and some of the X-ray pass through the patient, and past X-ray reach the detector, and a radiographic image is formed. So the main duty of detector is change the X-ray flux, X-ray intensity to the image. What's a radiographic image? What is a radiographic image? Radiographic image is in the picture of organ distribution. We call it anatomy, yeah? Because different attenuation property of tissue results in a having a distribution colors or heterogeneous distribution of X-ray transmission. An image receptor or image detector, both is correct, is a tool that change and convert the X-ray beam to visible image. There are two main receptors in radiography. First, called a screen film. You remember the radiography film? And digital detector, the new era in X-ray imaging, which is digital X-ray imaging. The first detector or receptor or sensor of X-ray is radiographic film. Radiographic film mostly is a transparent plastic sheet, mostly from polymers and polyesters. Like the covers which we mostly use for written hands and written papers, very plastic, very transparent plastic. But this transparent plastic coated with a radiation and light sensitive emulsion, some kind of chemical emulsion that is sensitive to light. Most of the time, it's a composition of the silver and halogens. For example, iodine, for example, or bore. I will talk about that. So, a sheet, a polyester sheet, which is coated by emulsion, sometimes in one side or sometimes in both sides, and a very thin layer, again transparent layer. And you know the thickness is very low, less than 1 millimeter, but when you look at it in magnified view, you can see this cross section. What happened when X-ray hits this radiographic field? It's very interesting process which happened inside a radiographic field. The emulsion which is coated on the sheet is composed or the very small granule of the silver and halide. For example, we have a silver which made an emulsion of silver. We have inside that caution. And when the X-ray or light, when the X-ray come through this emulsion, it, for example, by photoelectric interaction, one electron liberated and ejected from this composition. And so we will have ion of silver plus an electron which is ejected. The interesting thing is a normal element of silver is black in color and the ion of silver is transparent. It means that every point of the film which experience the photoelectric interaction will be transparent. Okay? This reaction results in formation of some black and transparent points in the sheet of film. For example, if you increase the number of photons, you will be more changing the, for example, ion to Ag or Ag to ion. So it means that we have a tool which is sensitive to number of photons, sensitive to energy of photons. But there is a problem, there is some difficulty in using film, because this sheet of film has very low thickness. Do you remember the equation of attenuation? N equals n0 e minus mu x. We have an x which is thickness of the medium, which is the attenuation medium. The thickness of film is very low, less than 1 millimeter. And so, as the thickness x is very low, the very low number of photons has the chance of interaction inside the film. Most of the photons pass through the film. So the film cannot detect them, cannot sense them. And there will be low efficiency of detection, and we need a high efficiency of detector in the X-ray imaging. Most of the photons that come from the patient's body pass through the film, and the film cannot understand how much really is the intensity of the photon. So one solution is to attenuate more photons by the film. How we can increase the attenuation of film, but preserve the same behavior? The solution is using a screen. This is what really used in the radiography imaging, a screen film. This is the cross-section of the screen film. We have a film, again, here, which is compressed and sandwiches by a thick, intensifying screen. What's the meaning of intensifying? It increases the intensity. How it works, how intensifying a screen or a screen work? It converts the X-ray photons to visible light. It's very interesting kind of material we have in the nature, and it can be made synthetically. How it works? For example, if you give it X-ray photons, it converts it to many visible light. So it is somehow intensifying, because one, or it amplify the number of photons. You give it 1 photon, it gives you 100 photons. Somehow it amplifies the number of photons. And if you put a very thin sheet of film here, these photons will reach the film. So,
Doctor, but it will stay same power because it come 1 photon, and that will after that will happen like 100 photon.
100 photons of visible light.
They stay.
For example,
yeah.
the energy of this is 50 keV, yes?
Yes.
And here is 100
So it will be less every time.
keV, okay? It's converted, one photon converted to 100 photon, but with lower energies.
Yes.
What is the advantage? One photon, if we use this setup without the screen, what we have, we have one photon and a sheet of film, and the probability of doing interaction or passing through without interaction depends on photoelectric and the point is. It may pass through the film without any interaction, and we miss the information of this photon. It comes from the patient photon. But when you intensify or amplify the number of photons using a screen, the probability of making an image, forming an image, will be increased. Forming an image will be increased. And the second advantage is this film or manufacturing of this film is very simpler than manufacturing of this film, because here we need only a film that is sensitive to visible light, like you know, the film which is used in the normal cameras, which is sensitive to visible light. It's very simple in technology compared to the film which should be, we have to be sensitive to X-ray. So we have a simple film which is sensitive to visible light. We have a screen that has spatial capability to amplify the number of photons, and so we put the film between two screens or sometimes one screen, depending on the technology, and after doing the examination, after imaging the patient, we get out the film from the screen sandwich and then try to make image from it. By this method, we increase the efficiency of our detector. But there will be somehow some disadvantages, which I will explain in the next session. These advantages, most of the time, has some disadvantages as well. But normally in the current machines, we use this screen film. Although this is an old-fashioned method, and the new methods we have digital detectors, which is very better than the screen film in terms of image quality and so on. So we have a comparison here. By using a screen, we have a higher number of photons, and we can have a better image quality. The main advantage of using a screen is if you want to have the same image quality here, the same image quality to this situation, needs to use very high number of X-ray here. Because, for example, imagine to have the same image quality in this situation, we need to have many X-ray photons, yes? Many, the same X-ray photons compared to this one. How we can do that? By increasing the MA, yes? By increasing the MA, we should compensate the absence of the screen. And it leads to harmful radiation to the patient, yes? We said that we should control the value of radiation to the patient. But when you use a screen, less X-ray will be used, will be penetrated, will be absorbed from the patient body. So this situation, this condition is less harmful compared to this one. And what about the digital? The second method of X-ray detection is digital detectors. Most of the time you hear that we have a digital radiography machine. We have digital mammography machine. We have digital angiography machine. When you hear that, it means the image receptor and image sensor is not a screen field. It is digital one.
That means number?
Sorry?
Number on the paper?
No, it's somehow a sheet. It's somehow a panel.
Yeah, like cardiac, cardiac شو اسمه؟
Cardiac.
الكاردياك شو اسمه؟ هذا الشيت مالته
شو اسمه؟
cardiac. We have the sheet for the cardiac.
Electrocardiogram.
Yeah.
In which machine?
I don't know.
ECG.
And he's speaking about ECG machine.
Oh, ECG. ECG
Yeah.
is not X-ray.
No, the same, digital, the same, that one.
Oh, no. I understand what you say. No. Digital means you have a panel. You have a panel, for example, a rectangular panel. And this panel is sensitive to X-ray, but you don't need to have a film. And the method is, when the X-ray hits this panel, it generates light, and then you have a light sensor, and there is no film. And this light sensor converts the light to the signal, electrical signal, and the electrical signal sent to the computer, and you can see the picture of patient directly in your computer. For example, in your tablet or your laptop, directly. Immediately after the exposure, you can see the patient image. But in the screen field, we have some process. After doing examination, you should take the film and go for some chemical process to make image in the field. This is somehow not immediately after the scanning, and you need a film and some difficulties using the film. But in the digital, when you push the button of exposure, 1 or 2 seconds after that, you can see the patient image in the computer without using the film.
Does it have the same quality or better?
Better quality. Better quality compared to film.
Is it more dangerous?
No, less dangerous, because as it is more sensitive compared to film, there will be less X-ray using for X-ray imaging. This new technology has better image quality, less harmfulness of the X-ray for the patient, and very fast and immediately after scanning and imaging you can see the image. And very importantly is, you have a file in your computer, and you can send it to another hospital, another physician, for example, another city. For example, imagine there is a small city, they have a digital radiography, but don't have a physician or radiologist to have diagnostic on the image. You can have another physician, another city, and send the image by internet and ask him decision on the patient. This digital, very, very helpful both for patient and doctors. Thank you. It's finished in this part.
For today?
No, not today. But this part, we have 30 or 35 minutes more. If you have prefer to have a break,
Yes.
10 minutes, what 10 minutes? not
Yeah,
more.
okay.
But after we'll